Solve the right triangle shown. Express all angles in degrees and minutes. This is 3 significant digits, and if we're expressing this in degrees and minutes, that means I'm going to round these to the nearest 10 minutes. This is using the guidelines that I saw before. 3 significant digits means to the nearest 0.1 degree, or to the nearest 10 minutes. So that's where I'm going to be rounding this to the nearest 10 minutes. All right, so in any case, let's see what I can figure out here. I can find c fairly easily using the Pythagorean theorem. I know that c squared must be equal to 26.5 squared plus 18.2 squared. And so c must be the square root of these. So let me plug that into the calculator. We'll do, oops, wrong calculator. Get rid of that one. We have square root of parentheses 26.5 squared plus 18.2 squared, which gives us 32 point, I'll go ahead and call that 32.1 kilometers. 32.1 kilometers. I'm rounding that to the nearest tenth of a degree because that's what these were each measured, rounded to. All right, now I need to find some angles. I don't have any angles on here other than the 90-degree angle, so my only recourse is to really say, okay, if I want to find this angle, the only 2 measurements that I have are these 2. Those are the 2 kind of measurements that I'm going to need to use. Let me think of SOHCAHTOA here. So SOHCAHTOA says if if I'm trying to find this angle, this is the opposite, and this is the adjacent. And you can see the in SOHCAHTOA, tangent is the ratio that involves opposite and the adjacent. So that means the tangent of A, this angle right here, is going to be my opposite, 18.2, divided by my adjacent, 26.5. But I don't want to, I can't take the tangent of something I don't know. So what I want to do is, to get rid of this tangent, I need to say, well, okay, that means I'm going to do the inverse tangent of this stuff. This is kind of like if you say c squared equals something, the inverse of a square is taking the square root. So if c squared is equal to this, then that means c must be the square root of this stuff. Well, if the tangent of a is equal to this number, then a must be the inverse tangent of this number. It's the same sort of relationship. So that's something I can plug into my calculator. The inverse tangent of 18.2 divided by 26.5, which gives me 34.48, approximately 34.48 something, which is going to be 34 degrees. I'm converting this to degrees and minutes now, so I'm going to subtract off the 34 degrees just to isolate the decimal, the part that follows my decimal point here, and multiply that by 60 to figure out how many minutes this is. And this is 28.85 minutes. If I'm rounding this to the nearest 10 minutes, that means I would call this 34 degrees and 30 minutes. Okay, that's angle A. For angle B, I suppose I could use angle A to find angle B, but I don't necessarily have to. I could do the same sort of thing. If I know this one, I could use my opposite and my adjacent sides. I know that the tangent of B is going to be 26.5 divided by 18.2. So actually I could do the same sort of thing here. A tangent of, because B is equal to the inverse tangent of 26.5 over 18.2. Which gives me 55 degrees, 0.51 something. So this is equal to approximately 55 degrees. Let me subtract off the 55 there and convert the rest to minutes by multiplying it by 60. Again, rounding this to the nearest 10 minutes, this gives me 30 minutes. One of the advantages of doing it this way is you can actually kind of check your work. This is 34.5 degrees. This is 55.5 degrees. 34.5 plus 55.5 is 90 degrees, so you can actually verify that three angles would sum up to 180 degrees without kind of assuming that they do. Let's see, this one, we know the lengths of the three sides, we know that the lengths of the angles, the measures of the three angles, so that means this equation, or this triangle, is solved.